Welcome to BAS 120. Getting a lot of questions, which is great. Thanks. Keep the questions coming on homework problem 6.9, chapter 6, problem number 9, where it asks us to go to the credit risk data. In treating the records in the database as a population, we're going to use the sample we took in problem number 2 to compute confidence intervals of 90, 95, and 99%. So here's the random sample of 20. If you remember problem number 2, it asked us to take a random sample of 20 out of this entire credit risk database, which we had, which I forgot how many records. Now, for this problem, it doesn't tell you, but I'll tell you, you can ignore this new data. So when we calculate our population standard deviation, because it tells us to treat this data risk as the population standard deviation. So what I did is I went in and I did standard deviation of a population, because I put the P there because it told us to put a P. Now, some of these formulas are a little different depending on the Excel version you have, so double check. But what I'm doing is taking a standard deviation of the population, and I highlighted all of these, ignoring this new data. And I got 4,821. So I'm going to utilize that over here as my population standard deviation. So this first block is we're calculating all of our confidence intervals assuming the population standard deviation is known. Okay? So if we assume the population standard deviation is known, we can take a sample mean, relatively easy. We just take the average of our sample. I happen to get 3,741. You might get something different because you randomly generated your sample. You might have something different. Your population standard deviation, of course, should be the same as mine, the 4821, because we both have the same credit risk data. And now we know we're ignoring the new data. So everybody should get the 4,821 for the population standard deviation. We know our population size is 20. It tells us the various alphas, 1 minus our confidence interval. Now, here's our sample standard deviation. Because we've taken a sample of 20, we're going to remember our formula. We're going to take our standard deviation here that we calculated from the population, and we're going to divide it by the square root of whatever our sample size is. So remember what happens when we're talking about a sample mean. A sample is going to shrink our standard deviation, because it's one thing to get one sample that's very unusual, but if you think about it, to get a sample of 20 people, and that mean of those 20 people is very different, is more unusual. So when we're talking about sample means, that's going to shrink or reduce our standard deviation. Then I just went in and got our z-score by using the norms INV, and we know our alpha, and we know this is a two-sided test. So all this is, I took the formula and I said 1 minus the alpha divided by 2, because this is a two-sided two-tail test. And then our upper limit's relatively straightforward. Here they did it, they added in the square root of this, but another way to do it, I'll show you an easier way since I calculated that stand, would simply be to say our upper limit is going to equal our mean plus our z-score times what we said the standard deviation of the sample is. And there's our 5,515. And the point is trying to make here is, as we become more, in order to become more and more confident, or as our confidence interval increases, our interval will widen. Or another way of saying it is, as the confidence interval decreases, our interval becomes narrower. Now, over on this side, they did the same sort of thing. Let me try to move us over. They did the same stuff, except they said, assume the population is not known. So now we have to take the sample standard deviation. Okay, so all we did here is I went over here and I did a standard deviation of the sample. Which you can see I did, for my Excel version, I did standard dev, which is a standard deviation of a sample, and I just put in the range. And then the rest of it was just relatively straightforward. And it's the same thing. If I want to be 99% confident, I have to have a very wide range. If I only need to be 90% confident, I don't need such a wide range. Hope this helps. Keep the homework questions coming. Have a great day.